It's Oliver.
Should I blame, oh, I should blame Oliver, but he's not here, so okay, I blame Oliver. Okay. Oh, by the way, stop a couple minutes early today. For those of you who are gonna sign up for Math League and haven't yet, we need to get that done, right? Okay, so don't let me forget. All right, so let me back up here a minute. So we did the first one. We plugged 2 into Q, took that answer and plugged it into P. It didn't work. And it didn't work because we have a domain issue. When you find the domain of the composition, you have to look at the domain of the original function, which for this problem is weird because it's Q of Q. But the original function is Q. What's the domain of that function? All real numbers. X can be anything, right? When do we have domain problems? When there is a denominator and when there is a radical, right? So we have no issues here, that's all real numbers. Here is your composition. This is what we got when we worked it out. What's the domain of that one? So the domain is all real numbers. It has to be both things, both domains. So I think we'll see something in this next one. Test?
Negative x times negative x is positive x. So we want to be only negative x squared.
Where are we looking? Right here?
Below that.
Right here?
Yeah.
Okay, remember, when you evaluate a function, or do a function, you take out the x and you plug in whatever it is you're plugging in. So for the x, I am plugging in negative x squared. Negative squared is positive, but there's still this negative out here. And that's x squared squared. It's exactly the same as when you do f of 2, you plug in 2, right? Whatever your function is, you plug in 2. I'm plugging in negative x squared. All right, let's try this one. I clear it up a little bit. Where do I start there? I start with my Q function. What's the domain of my Q function? All right, I'm going to keep track of that over here. All right, now I'm going to take that and I'm going to plug it into my P function. So I'll have 2 square root negative x squared. This is the answer. This is the composition right here. What's the domain of that?
No solution.
No solution. Can you possibly pick an x, a real x? Remember, we're real. Can you possibly put an x in there? No. So this domain is empty set. That problem isn't possible. That problem is not possible. What about this one? This one goes the other direction. So we're going to start with P. What's the domain of P? You always got to find your domain of your starting function. What's the domain of P?
Solution.
Oh, no, we got a solution here. Oh, don't get carried away. What can x be? 0 or bigger, right? Can't x be 0 and bigger? So here's my domain for this guy. Now, I'm going to take that and plug it into Q. So Q of 2 root x. Test, please watch this carefully. That means that this is my Q function right here. That means I have negative something squared. And the something is exactly what I'm plugging in. So that'll be 2 root x. So now it looks like I'm going to have negative, no, 4x. Won't it be negative 4x? Yeah. Now, if you were walking down the hallway and you found this function right here, wouldn't you tell me the domain is all real numbers? That's a linear function. The domain is everything. But it isn't. I mean, it is for this one, but not in the context of the problem. Because from the beginning of the problem, we said we were only allowed to have x's that are 0 and above. So the domain has to be both of these. It has to be the domain for the original function, for the first function. And then it has to be the domain of the composition. So put these two together. The overlap would be this right here, the intersection. Okay, see that? This is going to be a huge issue for some of you that go too fast and don't think. Because you're going to roll through the problem, you're going to get this, you're going to say all real numbers. Remember, if it's a composition problem, you have to meet whatever the standards are for the domain of the original function too. Lucy?
So, on C, how come, okay, so the domain is, it's an empty set because it's negative under the radical?
Mm-hmm.
Okay.
Yep. No matter what you square, it'll be positive, so put a negative in front of it, it's gonna be negative. All right, so having just had that conversation, would you try 5 on your own? Or with your neighbor? Maybe you and your neighbor. So you're building the compositions, both of them. So f of g and g of f. And you're finding the domain. Is today like city golf or something? Is that where she is?
Yeah, they have
City today. Beautiful day, probably wetter than heck out there.
Oh, yeah.
It's so nice out. It's really cool. What is it called?
No, it's just kind of. I remember they did that last time.
No, it's negative infinity to 0. It's 0 to negative infinity.
He's gonna golf at like 8 in the morning.
You
Yeah.
said 0 to negative. I said 0 to negative.
Is it cold?
Negative infinity is all negative numbers. You just said 0 to negative infinity. I heard you say 0 to negative. It's just 0 to infinity. But you got negative infinity.
Oh wait, no, that's for something else. Never mind. And that's the domain of the original.
So it's gonna be 1. At least we got the right How do you get the domain?
So what is it?
It's 1 minus x.
Oh, which one did you do?
That
So
one
you
was
said
mine.
two.
And for my
It's okay, I have to do it.
Oh, it's because if it's anything greater than 1, no, because that's 2. That's 1 minus 1.
Yeah, so it can't be like a number.
Okay.
So I'm so lost.
When I was doing that, I was keeping the negative. Graphs. These are graphs. We just don't write them.
Alright, I'm hearing some really smart people with different answers than mine, so I'm not sure now. I'm starting to doubt myself. But this is my first stab at it. Oh, yeah.
cracked.
How wonderful. It's not even Oliver's fault. We can't even blame Oliver.
Plug in negative 5.
Like she's
Somebody at the door.
and there's this girl that looks exactly.
Now I got somebody at the door with my crashing iPad.
They just can't be great at
All right. Oh, Mr. McGlynn, my iPad just crashed.
I can't help it.
Tell-
Loading my phone.
Right now it's a B minus, I just got a C minus. Yeah. But it's so bad.
Everyone say hello, Mr. McGlynn.
Go Irish.
Hello, Mr. McGlynn.
No.
Oh, you guys, he's an institution here. He was the athletic director. He was the vice president for something, like facilities.
Coach
or
football.
something, Coach football. Taught way back before I came.
Yep, yep, English and speech. Yes,
Yep.
absolutely.
Institution, cathedral history right there. And have you ever listened to the football games on TV or on the radio?
Yeah.
He's the one that's in the background going,
Bye, Mrs. Ford.
bye. All right. Okay. I said that the domain of G was everything between -1 and 1. Now, here was my logic. You tell me if I'm wrong. If I put in -1, or if I put in 1, I get 0. Right? If I put in a number like -2, that wouldn't work. Agreed? And +2 won't work. But if I put in a number like 0, it will work. So I said that's my domain right there. Does that make sense to everybody?
Wait, why wouldn't a negative like 2 work?
Because what's 1 minus -2 squared? 1 minus 4, which is -3. And then we have that, right? Yeah. So then I went ahead and took that guy, plugged him into F, and got this. Right? What's the domain of that? All real numbers. So again, this is one of those problems where you gotta be on top of things. Because if it says what's the domain, you might be tempted to say, oh, the domain is all real numbers. But it's not, because you have to include this. So that's the answer to the domain. With me, folks? Now I've got the same thing over here. Functions look different. So f of x is x squared. When I plug that in to G, I got the square root of 1 minus x to the 4th. I said that has the same domain. There are a couple ways you can think about it. One is factor that. This is always positive, so I don't need to worry about it. And then that's the same as this one. So again, that was the domain of my answer. Okay, you guys with me? Everybody okay? All good. All right. Now, we're going to do the opposite. We're going to what we call decompose a function. Function decomposition. We're going to decompose it. So here is like the answer. And you need to tell me what f of x and g of x are, that when I put them together, I got this answer. All right, this is an easy one. Think about it for a second, shout it out. What do you think my functions are?
X minus 5 equals 0.
Like that? I actually think he's right, guys, because if we build this composition, we start with g of x, which is 2x. And then we take that and plug it into f, which would be 2x minus 5. He's absolutely right. Now, he knew this function does two things. It multiplies by 2 and it subtracts 5. So he said, I need a function that multiplies by 2 and subtracts 5. The order is important. He got them in the right order. If you mix them up, you won't get that function. You'll get 2x minus 10. But he's right on target. Good job, Peter. All right, what about the next one? What do you think about the next one? You want two functions so that f of g of x is x cubed plus 1 squared. Which one do you start with? So what do you want g of x to do?
And then x squared.
Is that the only option?
No.
What would be another one, Sydney?
Make g of x x cubed, and then make f of x x plus 1 squared.
Right? Nicely done, Sydney. All right. And finally, these two. Gotta start with F. What do you want F to do? Root x. So it's going to take x and take the square root of it. And then what do you need g to do? Is the cosine of that. Perfect. Very, very good. All right. Order is important, so pay attention to that. That you got. All right. Anybody know what we mean by implicit functions? Get calculators out. You know what we mean by implicit functions? Never heard that word before? All right. Well, let's talk about this shape. You all should know what shape that is right there. What shape is that? Boy, that's not a parabola.
Square root function. Why regular identity?
A straight line would not have any squares in it. Right? A circle. This is a circle centered at the origin with a radius of 5. We talked about that back in P something or other. You need to know that's a circle centered at the origin with a radius of 5. So I could graph that on the blackboard. Just like that, right? Is that a function?
No.
No. So I can't, in that form, graph this on my calculator. So what I need to understand is, if I could split that equation apart into two pieces, would the pink part be a function? And would the blue part be a function? So if I graphed this as two separate equations at the same time, I would get my circle. Agreed? So to find the implicit functions, these are called the implied or the implicit functions. The top half of the circle and the bottom half of the circle. Get y by itself. So we're going to subtract x squared. By the way, isn't that how we graph things on our calculator? Y equals? So we're getting y by itself so that we can put it in. And then what is y going to equal?
Plus or minus.
It's gonna be plus or minus, so I'm gonna write it separately. You cannot split this, boys and girls. The minute you put that minus sign in there, this stays this. Take the square root of both sides, positive and negative. So here are my implicit functions. Is that a true sentence? Is that a true sentence?
No.
You cannot individualize radical parts of a sum or difference. You cannot make this a 5. It stays the square root of 25 minus x squared. Now, let's graph them. I'll just use a standard window, so I'll zoom 6 because I don't know what I've been doing on my calculator. And then I'll type in the square root of 25 minus x squared. And then I'll type negative square root 25 minus. Now, tell me what you see.
Circle, but it doesn't touch Y.
Okay, is it a circle? Does it really look like a circle on there? It looks a little more like an elliptic or an ellipse. An ellipse. It looks kind of elongated this way. Let's talk about that for a second, because this is going to help us maybe in the future. When they built your calculator, and I have no idea why they did this, I'm sure there's a reason. What shape is the screen? It's a rectangle. And so when we zoom 6, when we set up a standard window, we're saying this is -10 and this is 10, and this is -10 and this is 10. The problem is the hash marks this way are more spread out than the hash marks this way because the screen is wider than it is tall because of the shape of it. So if you go to zoom, you will see one of your options is square. So if you zoom square, it will square your screen and give you a more accurate picture. Okay? Now I know they don't connect. I make they connect on your calculator. Yeah, I don't know why that is. I don't know. I'm sure there's a reason for that too. I don't know what it is. But squaring the screen adjusts the dimensions so that now you're looking at a square instead of a rectangle. Okay? And there's your circle. So, how did we graph a non-function on our function calculator? We broke it down into its implicit functions. These are the implicit functions. Y equals. And there's 2 of them. The top half and the bottom half. Because each of those is a function. All right, how about this guy? Tell me what you think about this. First of all, I'm going to get the y thing by itself. Is that okay? Now, what shape do you think that is? Think about that for a second. Well, it's an absolute value, so it's going to be a V, but it's the absolute value of y, which means it'll be a V sideways, right? And wait a second, it's a V sideways, so is it a function? No. So in order to graph it on my calculator, I'm going to have to write it as its implicit functions. Y equals and y equals. Now, we know that y can equal x minus 1. Would you agree with that? But what else can y equal?
1 minus x.
Not negative that, well, negative the quantity, which would be negative x plus 1.
Wouldn't that be the same as 1?
What?
Would that be the same as 1 minus 2?
Uh-huh, yep, so it doesn't matter, yep, yep. All right, so let's graph those equations. And something interesting is going to happen here. I want you to tell me what's going on.
Oh, wait. This is X.
It's a big X. So this is actually what you got, right? Now I want you to think about something for a second. Would you agree that if, let me look at a regular absolute value for a second. On this side of the absolute value, this is the picture when x is positive, and this is the picture when x is negative, right? Now let's look at this picture for a second. In this equation, let's look at the original equation right here. This is positive, always, right? No matter what, that side of the equation is positive. So if y has to be positive, then doesn't this also have to be positive? So that's this branch right here. Now, when you did this, you said, okay, now I'm gonna let this be negative. Now y is still gonna be positive, but I can move the negative over here if I want. And that's this branch right here. Because this is still positive, but now your y has to be negative for the other half of your absolute value. X is positive for, well, in the basic curve, x is positive for one piece and negative for the other piece. Y is positive for one piece and negative for the other piece. But this has to stay positive because absolute values equal positives. Just remember that absolute values are V's. If it's an absolute value of an X, it's going to be a V like this. If it's an absolute value of a Y, it's going to be a V like that every time. Same thing with parabolas. This is going to be a parabola opening up or down, and this is going to be a parabola opening sideways. All right. Good news. All right, what's next? A snowball's chance. All right, let's read this and see what's going on. This came out of your book. All right, I'm ready. What do you think? I've kind of written down the facts. Where shall we start?
Area of
Do I need to find the area of the original snowball? The volume of the original snowball? Because this is changing in volume. Okay, so what's the volume of the original? I'll denote it like this. It's a sphere. Anybody remember the volume of a sphere? 4/3 pi r cubed, that's exactly right. And so the original volume, wait a minute, what was our radius? 2. So 32 pi over 3 cubic inches. Did I do my math right? Now, what is happening to this volume? So he makes the snowballs and puts them in the freezer, and this is what their volume is. But what's happening to them? They're decreasing by 1 every 40 days, which is 9 times. So the new volume would be 32 pi over 3 minus 9. Would you agree with that? Okay, let's get a number for that. 32 pi, let's use our pi button, divided by 3, minus 9. Did you get 24.51? 03. Okay, so what does that number represent? That's cubic inches. That is the volume of the snowball after a year. Now, what did I want to find? The diameter of the new snowball. So, doesn't 4/3 pi r cubed have to equal 24.5103? And this is the new radius now, Marin?
Is the 9 because that's how many times it decreased?
Yep. So how do I do this now? Maybe I'll start by, I've still got this number on my calculator, so I think I'm just gonna multiply it by 3/4. Does that make sense to you?
Yeah.
All right, I'm keeping the number, I'm not rounding it off, but this is what I've got now, multiplied by 3/4. So now maybe I'll divide by pi. So r cubed still on my calculator, 5.85. And then what do I need to do? Cube root it. Now, you can literally cube root. You can also raise to the 1/3 power. Your cube root is in your math menu. If you just press your math button, you see the cube root right there in the list. So if you want to use that, you're going to cube root your answer. So second answer, I got 1.80 inches. How about you?
Wait, how did you get, when you click the cube root, how did you get the cube root the answer instead of typing?
Press second answer. Press your second button, and then down at the bottom, you have an answer button. And it just pops that right in there for you. All right, did we finish that up? Yes, 1.4 done. Awesome timing. So 1.4 will be due on Wednesday. All right, who's signing up for Masters? Let's go. Who's buying a t-shirt? Let's go.
This is for the last day, so I have nothing.
I sent you an email. It's in Schoology. and it's on the board. Friday is the last day. But what happens when we wait till the last day and then we're like, damn, and we start pulling up and have to go home? And it's out of luck. Don't wait till the last day. People, there are 4 out of this class signed up. That is pathetic.
I just need to bring cash.
I'm also gonna get a t-shirt.
Oh, okay.
I'm last. No, I'm religion. No, I'm Spanish. I'm in Spanish.
Zoe, are you here too, right? Yeah. Okay, good. Don't forget to sign up, people. Hey, Sammy bought a t-shirt. Who else is gonna buy a
Did you
t-shirt?
take Spanish? No. I'm doing it. So I couldn't get around to my dad left New York for me. Yeah. So I'm doing it. Yeah, our school there. So it was the last day. I know, but you know. It's just like. It was nice retaking it. It was the exact same coach. The exact same Yeah. So did I, but what if I do really bad on the written?